Okay, we are about to begin section 8.8, dividing by a monomial. This is from Bob Jones University Press, Algebra 1, second edition. Before I begin, I have a question for you. Owls go to school, did you know that? And they even have favorite subjects. And Mr. Owl has two favorite subjects. What are they? Well, first, he loves history. But his most favorite subject of all, of course, is algebra. So, dividing by a monomial. Many of the concepts that are involved here in dividing by a monomial, we have covered more than once from various different angles. You simply have to remember what you've already studied. You have to remember how you multiply and divide exponents. You have to remember what happens with positive and negative numbers. And you also have to make sure that you understand factoring. And we sort of wrap it all up in the same package, and that's what we're going to be working on. So for example, let's say that we see a problem, and it says simplify 32xyz divided by 4x. Well, first off, we're going to immediately change this into a rational expression where we have a numerator divided by a denominator. And we really like to have expressions that are in rational expressions because we've learned that any number divided by itself is always and forever equal to 1. And it's that principle that allows us to cancel common factors. Remember back when we did prime factoring and we learned how to reduce fractions? Like if we had 30 twelfths, trying to do too much in my head, 30 twelfths, and we saw that 30 was equal to 2 times 2 is 4 times 3. 2 times 2 is 4 times 3 is 12. Can't do it in my head. I had it all figured out. 2 times 3 times 5 is what I needed. 2 times 3 times 5, while 12 was 2 times 2 is 4 times 3 is 12. You could cancel factors of 2 because 2 divided by 2 is equal to 1. You could cancel the 3's. 3 divided by 3 is 1, and 1 times any number is the number itself. And you reduce this down to 5 halves. You saw that you had a common factor of 6. 6 times 5 is 30. 6 times 2 is 12. And right here with these prime factors, 2 times 3, is where we got our factor of 6, by which we reduce this number to a rational expression in lowest terms. Well, that's really all that we're going to be doing in section 8.8, and continuing on through the rest of your math classes is using the basic principle of common factors and reducing of fractions to simplify algebraic expressions. So let's make this much less busy here. Now you can always revert back to prime factoring something if you need to, but it also helps a whole lot if you know what your multiplication facts are. If you know that 4 times 8 is 32, then you see that there is immediately a factor of 4 in common here. And I'm just running over this because I don't need to reteach this. 32 over 4, we have a factor of 8 left. X in the numerator, x in the denominator. X divided by x is equal to 1. So what do we have left? We have 8yz. That's all there is to the problem when it says simplify this expression. Now we use the principle that any number divided by itself is equal to 1 to cancel factors of x. But you can also use this piece of information that you learned from how to manipulate and how to deal with exponentials. If you have 2, they use m and n, x to the m times x to the n times x to the n. That's x to the m plus n. What that means in real English is if you have 2 exponential expressions that you're multiplying together, as long as their bases are the same, the base here is the x, you keep that base and you add their exponents together, 2 plus 3. So this is x to the 5th, because what this says is use this expression x as a factor 5 times. Well, is that really what this is? Well, let's see. X squared says use x as a factor 2 times. Times x cubed, which says use x as a factor how many times? 3 times. Plus, not plus. Plus is a term, multiplying, that's when it's a factor. X times x times x. How many times in this expression here do we have x being used as a factor? 1, 2, 3, 4, 5 times that we use the expression x as a factor. So you remember that when you multiply exponential expressions, you keep the base and you add the exponents. Well, what happens if you have 2 exponentials, you're dividing them. You have a fraction. This is a rational expression. It looks like a fraction where you're dealing with exponents. As long as the base is the same, you subtract the exponents. This is the theoretical rule, which, what are m's and n's and p's and q's and r's and z's and alphas and betas? Well, let's put this into some real numbers here. If we have x to the 4th divided by x squared, you can't say it's 2x, but let's follow the pattern. The bases are the same, so we're going to say x, the first exponent minus the second exponent. That gives us x squared. What does x squared mean? It means use x as a factor 2 times. Well, what do we really have here? This x to the 4th says use x as a factor 4 times. It's a lot quicker to write x to the 4th than to write out 4 x's. And especially if you have something like x to the 21st. Wouldn't be any fun at all to have to write out 21 x's. We want to divide it by x squared, which is x used as a factor 2 times. At the beginning of this video, any number divided by itself is equal to 1. X divided by x is 1. X divided by x is 1. 1 times anything doesn't change the value. Here you have x times x, which is equal to x squared, which is exactly what we had over here. So, when you divide rational numbers that have the same base, you subtract the exponents. So that's all that they're wrapping up all together in section 8.8, which is multiplying monomials. So let's go ahead and do another example. And we have 54x squared yz, 54x squared y z cubed divided by 3xy z squared. This is example 3, page 351. Now this might look a little bit scary to you, just because it has this big jumble of letters and numbers in it. But it's nothing to worry about. First, consider the coefficients. You do have to know your vocabulary. If you don't know your vocabulary, you can't do the work. 54 and 3. 3 is a factor of 54. I happen to know it, but you can also remember your little, how do you figure out if 3 can go into a number? You add the digits. 5 plus 4 is 9. If you can divide their sum by 3, 9 divided by 3 is 3. Then the whole number itself is divided by 3. So 3 goes into 54, 1, 8. 18 times when we cancel out the factor of 3. And I'm just going to go ahead and write the answer. I have 18. I have x squared divided by x. X to the 2 minus 1. That gives me an x. The y's completely cancel out. Z cubed, z squared, z to the 3 minus 2 is z. There really isn't a lot of work to these. It's just understanding what you're doing. If you get flying so quickly and you give me this example, that answer there, it's wrong because there isn't any work to show me. So be careful that you understand what you're doing. Show me the answer. Now, okay. What happened way back in the back, way back in 5th grade when you were working with fractions. How did you add fractions? Well, you maybe started off with 1/3 plus 1/3. And you learned that as long as this number here on the bottom was the same, you could just add the numbers up here on the top. 2/3. Okay? And then you got to where, I want to add 1/3 plus 1/2. Had to come up with a common denominator. You went through the process and you learned that 1/3 was the same as 2/6 and that 1/2 was the same as 3/6. And then you learned to write your expression this way. And you learned that if the denominators were the same, if it's divided up in the same number of parts, you add the exponents. 2 plus 3 over 6 is equal to 5/6. Then you learn to go backwards. And you could separate this out. If you had 2/3 and you wanted to come up with 2 terms that when you add them together you get 2/3, you learn that that was the same as 1/3 plus 1/3. Well, that's sort of the principle that we're using here with rational expressions. Very straightforward. Has to do with the fact that you have to have a common denominator. And I'm going to look at example number 5 on page 352. Simplify 12x squared plus 20x divided by 4x. We want to rewrite this problem as a rational expression, which means we want to put it in fractional form. 12x squared plus 20x. These parentheses here are very important. If you didn't have the parentheses there, if they were omitted, you would have 12x squared plus 20x divided by 4x because of order of operation and symbols of inclusion. You now have 12x squared plus 20x, all of it divided by 4. And that would be like Well, let's just go ahead and move on. Now you're going to want to break this apart into two rational expressions, 4x plus 20x divided by 4x. I want to go ahead and do a companion problem at the same time with numbers. Let me see if I can, rather than try and make up one, 15 plus 27 divided by 3. I'm going to step out of the picture here. 15 plus 27 divided by 3. That's the same as 15 plus 27 divided by 3, because 15 thirds plus 27 thirds, all they've done here is you have the same denominator, you add the numerators. That's all that we've done over here. 12x squared, 4x, 20x divided by 4x. Now, to solve this problem, you cancel a common factor of 3 to leave a 5 in the numerator. 3 cancels, and here we have 3 times 9 is 27. So your answer becomes 14. Let's see what happens here. We use the same exact principle with these algebraic expressions. Now, I got a little bit too excited in the size with which I was writing, so let's just go this way. Do I have any common factors here? Yes, I have a common factor of 4, which leaves me a 3. I have a common factor of x. X squared divided by x leaves me 1x in the numerator. So I have 3x plus a common factor of 4. There's 5. I have x and x are common factors, which leaves me the solution to this problem, 3x plus 5. This right here, principle right here, is very, very important, crucial. I know you get so tired of me saying, oh, it's important, it's important, it's important, it's important. Well, if you're going to be successful in math, it is important. Some things that we are not excited about, the fact that we're not excited about them or not particularly thrilled with what we're studying, doesn't change the fact that that's just the way it is. Okay. Sound more like Mom all the time, don't I? Let's see. Let me try one more problem for you, and this one is going to be even a little bit more different because we're dealing with negative signs. This is example number 6 on page 352. 8x cubed plus 16x squared minus 4x divided by a negative 4x. Now, at least when you're working with numeric fractions, they're not algebraic, you don't have to worry about dividing by a negative sign. This is different here. What's our denominator? It's a negative 4x. We have 3 terms in the numerator divided by a 1-term denominator. That can be rewritten as the sum of 3 separate rational expressions. First you have 8x cubed divided by what? Divided by a negative 4x plus 16x squared. Oh, I wish you could see this. The 2 roosters are facing off in my backyard. Looks like they're going to be friends instead of fighting. Plus 16x squared divided by a negative 4x plus a negative 4x divided by a negative 4x. 3 separate fraction-looking creatures, they're rational expressions. Cancel common factors. 8 divided by a negative 4 is a negative 2. X cubed divided by x is x squared. Plus 16x squared divided by negative 4x. 16 divided by negative 4 is negative 4. X squared divided by x is x to the 2 minus 1, or x. Plus, now be careful here, negative 4 divided by negative 4 is positive 1. X divided by x is 1. Your answer, your partial right here is a positive 1. It's not 0. This is not negative 4x minus a negative 4x, but it's negative 4x divided by negative 4x. Remember, any expression divided by itself is always going to be equal to 1. Now let's go ahead and rewrite this. We don't want to have plus a negative. So our final solution, 2x squared minus 4x plus 1. Negative 2x squared minus 4x plus 1. Subtraction, we're subtracting 4x, is the same as adding the opposite. And if you will go ahead and verify in your book on page 352, example 6, you'll see that the solution is exactly what we have written here. And this is the conclusion of the video teaching for section 8.8, Dividing Monomials, Bob Jones University Press, Algebra 1, 2nd edition.